All right, so we are going to start the next section in chapter 1, and we are going to be covering section 1.3, which is titled Complex Numbers. So in this video, I just want to kind of go over the basics of what leads up to a complex number, which is actually going to us be talking about an idea called an imaginary number. We'll do some examples, and I'll wrap up this first video and explain what will be in the next video. So when it comes to complex numbers, before we can tackle that idea, the first thing we must talk about is what is called the imaginary unit, or as some people just call this, the imaginary number. Well, in this book, they use the word unit, so we'll go with that. It's defined as the imaginary unit, which we will just use the letter I, is defined as the following definition. I is equal to the square root of -1, right? And so we define it that way because where it benefits us in this class is that if you were to take this and you were to square both sides of the equation, what that ends up converting to is maybe a little bit more simpler definition that might help us later, where I squared is equal to -1. Now, these two are equally as important because we will see problems in this class that just have the regular imaginary unit I, but we'll also see some problems that run into an I squared unit. And what we can do is anytime an I squared shows up, we can just replace that with -1. Now, what I want to do here is I would like to simplify a few square roots that involve the imaginary unit so that you're prepared for this as well. So starting with number 1, it says take the square root of -8. Now before we get into that, you might notice up at the very top, I kind of show you a breakdown way of how to handle the square roots of negative numbers. So anytime you are dealt with or have to deal with a square root of -m or negative any number, what you can do is we can rewrite this as two separate square roots. We can write it as the square root of -1, which will take care of the negative part, and we can also multiply it by the square root of m, which takes care of the m part. Now, the reason we break it down this way is because from our last slide, we know by definition that the square root of -1 is going to end up equaling the I term right here. All right, so I apologize, y'all. I'm making this video at my house and somebody knocked on my door, so I had to pause the video real quick. So as I was saying before the knock on my door, we're going to break down the square root of -m into the square root of -1 times the square root of m, and then we know that the square root of -1 has a definition of I, so we can just write that as I times root m. So if we go back to the first example here where it says take the square root of -8, what we will do is we will rewrite this as the square root of -1 times the square root of 8. And then by our new definition, we know that the square root of -1 is going to give us I, and then we will bring down the root 8. Now, what you have to remember from a previous class is how do you break down square roots? So with square roots, we typically break those down with factor trees. And so we know that 8 is the same thing as 4 times 2. And we know that 4 is the same thing as 2 times 2. And so all in all, 8 can be broken down into 2 times 2 times 2. Now with square roots, what you're trying to identify is a pair of numbers. So in this case, I was able to pull out 2 of the 2's as a pair. And what that allows me to do is that pair will come out front with the I and make it 2I. And then any number that you don't circle, which is the additional third 2, goes back inside of your square root. So in the end, the square root of -8 can be simplified into 2I times the square root of 2. Now, you only have to do the factor trees when it's not a perfect square root. On number 2, sometimes the square roots we run into work out very nicely. So what about this one? You have the square root of negative 121 minus the square root of 144. Well, with the first one, since it's a negative number, I can write that as the square root of negative 1 times the square root of 121. And since the second one is not negative, we'll just leave it alone as it is. Well, going from left to right, the square root of negative 1 I know is I. The square root of 121 is actually a very nice number. It is 11. And then minus the square root of 144 is just 12. So those simplified way quicker. And if I were to write this in a little bit nicer way, I would just write this as 11 times I minus 12. And so that is the value for number 2. Number 3 has a few more terms in it, so we'll break them down one at a time. You've got negative 4 plus the square root of negative 20 divided by 2. And so what we're going to do is, like on number 1, I need to break down the square root of this negative number. So this would be negative 4 plus the square root of negative 1 times the square root of 20, all divided by 2. Now, the nice part is that we know that the square root of negative 1 is just going to be an I term. And since the square root of 20 is not a perfect square root, I need to come over here to the side, and I'm going to break down what 20 is. Well, I know that 20 is 4 times 5, and I know that 4 is 2 times 2. The 5 can't be broken down any further besides using the number 1. Well, you'll notice, like I did on number 1, I picked up a pair of 2's that I'm able to factor out with the I. And so those two 2's that I have circled come out, and that makes it 2I. And then the 5 that I don't have circled goes back inside the square root as root 5. We will divide all of that by the 2 on the bottom. Now, normally you could probably say you're done, but the difference here is that if you look at all 3 of these numbers, they all share a 2 in common. And since they do share a 2 in common, what we have to do is not only cancel the 2 on the bottom, but you have to cancel the 2 in front of the I. And if you take away 2 from the 4, you have 2 left. And so actually your fraction ends up going away, and you are left with negative 2 plus I times the square root of 5. And that would be your simplified answer for number 3. All right. Now, on those first 3 examples, we really only dealt with the basic power of I, but as I've shown y'all on the first slide, I can have a different power. So the 2 that we've already seen are these first 2. We know that I is equal to the square root of negative 1, and I squared is equal to negative 1 because you're squaring the root value. But there are actually 2 other I powers that might help you to know. Starting off with I cubed. Since I cubed is just another iteration of I and negative 1, what you're doing is you can rewrite this as I squared times I. And since we know that I squared is negative 1, it ends up becoming negative I. Likewise, if you do I to the 4th, that's the same thing as I squared times I squared, which would be negative 1 times negative 1, which is just positive 1. And that gives you the 4 different values of the i's. Now you'll notice I went ahead and wrote the next 4 out as well, I to the 5th, 6th, 7th, and 8th. But you'll notice all that's happening is your values are repeating themselves. That's one of the nice things about this imaginary unit, is that as you go through higher powers, you will end up just using the same 4 values every time. So to make this a little bit easier on you, I don't want you to memorize every I power. Instead, if you know these 4, you can work out any power of I problem that you see in this course. So as long as you know that I equals I, that's pretty obvious. I squared is equal to -1. I cubed is equal to -I, and I to the fourth is equal to +1, you will be fine for any power of I you see. All right? So let's finish up this video by doing a few examples of how to deal with I powers. So on number 4, it's asking you to find what is I to the 17th power. Now you may be wondering, I thought you said we only had to know the first 4. How do we deal with these higher numbers? Well, here's how you're going to do it. Since the power of I repeats itself every 4 units, what you're going to do is you're going to take whatever the power of I is, which in this case is 17, and we're going to do old school division on this. So I'm going to divide it by 4. You might remember from when you did grade school division, 4 goes into 17 4 times. 4 times 4 is 16, and that gives you 4 remainder 1. The reason I'm doing it this way is because what happens is I raised to any power that's bigger than 4 is going to be equivalent to I raised to the remainder you get when you divide by 4. So we end up getting I to the first power. And so what you should know here is that if you do I to the first, that is just I. So that's equivalent to I to the 17th. Now, moving over to number 5, what if you do it twice? What if you have I to the 8th times I to the 6th? Well, I probably wouldn't do it as 2 separate problems. Instead, I would use my properties from algebra that say if you multiply 2 exponents together, so I to the 8 and I to the 6, this is actually equivalent to adding the powers of I together. So you end up getting I raised to the 8 plus 6, which is equal to I to the 14th. And then what I would do is work out the exact same thing here. And so we are going to end up getting, I'm going to take the 14 and divide it by 4. So 4 goes into 14 3 times. 3 times 4 is 12. And so you get remainder 2. So I to the 14th is actually the same thing as I squared, because you're just pulling the remainder value. And we know that I squared is equal to -1 from our chart. Now, sometimes you can get some really big numbers. So what if you get I to the 100th power? Well, what we will do is we will take the power of 100 and we will divide it by 4. Well, 4 goes into 100. Let's see, 4 goes into 10 twice. So 2 times 4 is 8. So that's 2, bring down the 0. And then 4 goes into 25 times. 5 times 4 is 20. And so you get a remainder of 0. So I to the 100 is actually the same thing as I to the 0. And from your knowledge that you should know of exponents, anything raised to the 0 power is just going to end up being +1. And that's how you can deal with I raised to any power that I give you. In the next video, we're going to transition from doing just imaginary unit stuff into actually what a complex number is. So stay tuned to the next video for section 1.3 to see how this plays a role as a complex number.